Good morning, good afternoon, everyone, and thank you for joining us on this presentation and discussion on reducing costs and emissions in New York through virtual power plants. And with us today is John Cordi. John is the Director of Demand Flexibility and Virtual Power Plants at the New York Power Authority, and he brings over 2 decades of experience spanning both the regulatory and operational spheres. So really looking forward to the presentation. And John spearheads the strategies to affordably decarbonize NYPA's customer sites, really enhance the customer and grid reliability and resilience needs through optimization of distributed energy resources. And he also previously was in senior positions at the New York Independent System Operator, NYSO. And so really glad to have John's experience and knowledge here to share with us around the initiatives and the solutions that he's been working on around reducing costs and reducing the emissions for NYPA. So John, I'll give it to you and look forward to speaking with you around the opportunities that you're going to be discussing with us.
Thank you. Thank you very much for the introduction, Adib. It's always a pleasure to see you and the Xendee team. Thank you for letting me be a part of your Xendee University. I hope it's been an excellent week for you. For everyone on the call, good morning to some of you folks on the East Coast and Central Time Zone. Good afternoon to those of us on the East Coast. So great to be here. I'm going to go through, really, I'll say it's NYPA's VPP origin story and the role that Xendee has played, not just in looking at projects and working with customers, but also our unique VPP model and how we came to it, the products that comprise our program, our business and financial model. Xendee was critical in us developing that and understanding that. And then at the end, we'll run through a project that we designed using Xendee and the results that we got that were pretty favorable, I think, for the project, for the customer. So with that, I'll go to my next slide. So you have to start with a little bit about the New York Power Authority. We were founded by Governor Franklin Delano Roosevelt. Most people call him president, but he founded us. So we like that governor title. He was governor when he founded us. And from our founding, way back, almost 95 years ago now, to our current Vision 2030 renewed strategic plan, NYPA is entrusted by all the New Yorkers, all the politicians, all of the energy providers in New York State to be an exemplary leader in the energy industry. And we take that responsibility very seriously. We have approximately 2,400 employees, a little bit more right now. We have owned and operated for quite a while, 17 generating facilities that produce about 30,000 gigawatt hours per year. That's about 25% of New York's total electricity, and about 84% of all the power we generate is hydropower, clean hydropower. I like to say that we are the original clean, sustainable power source in New York State. We've also recently been enabled by our New York State legislature to begin a renewables program for grid scale projects. And so currently underway, we have about 5.5 gigawatts being developed by our New York Renewable Energy Development Organization, a subsidiary to us. They have 45 individual projects going on. In addition to those, they have about 146 distributed energy storage projects. I think all but one of those are in actually New York City. So quite a lift for New York City, which has always been resource challenged. And we also own a little bit more than 1,600 transmission circuit miles. That's growing, we're developing. You'll see another slide that talks about it. Sometimes people don't understand we also are a customer solutions entity. So we offer energy efficiency services and advice to our customers. We have DER advisory services to help them develop. A lot of solar and batteries been produced for our programs. We are also New York's largest installer of EV chargers. And most people are not aware that we also run the canals system in New York, the world famous New York Erie Canal System. And just to give a little bit of color, this represents the many fleets we have. We are throughout the state of New York. We don't have a territory like most utilities would have a territory. We are statewide. We are empowered by law. So when we are undertaking projects, we're undertaking programs, the New York State Legislature has put it in statute, put it in law, that we're able to do these. So this represents the many generating facilities we have across the state, ranging from hydro to battery projects to clean small glass plants in New York City. Jump to slide here. This slide represents the transmission we own. So all of these lines you see in here is the bulk electric transmission system in New York State. Anything with color on it is transmission that NYPA owns or is NYPA developing, and in some cases remodeling. You see this purple and green line coming down from Canada down toward the middle part of the state. We have a very unique customer base. The legislature not only tells us what we can do and cannot do, it also tells us who we do business with. So our customer base is founded in statute as well. And so just to give a sampling, generally talk about 5 sectors of customers we deal with at the Power Authority. We have a lot of municipalities and cooperatives that run their own energy systems throughout the states, 51 of those. We have numerous local governments as customers and the K-12 school programs. A lot of for-profit businesses that are coming into New York State, incentivized, may get some economic development power from our Niagara Falls facility or a St. Lawrence hydropower facility. Also, a number of not-for-profits are eligible for services from the New York Power Authority. The city of New York, all of southeastern New York, is a customer of ours, as well as all the New York State agencies. So all of the corrections facilities and the healthcare facilities throughout New York State are eligible to be customers of ours. And while they're a tremendously diverse group of customers in tremendously diverse geographic regions and electrical topological challenges, what we find is that our customers really have a shared goals that they're working toward. And so on this slide on the bottom, we talk about, energy affordability and equity, the key issue for our state this year. Site and grid decarbonization, a challenge we've all been working toward. We say, our culture, our society is asking for us to have a cleaner, better grid, and we are actively working toward that with our customers. Everyone's looking for a site and grid reliability. If you want a facility, you'd never want the lights to go out. Certainly, if you run a large distribution territory or transmission line, you don't want the lights to go out. And then site and grid resilience, the ability to absorb any mishaps that may happen along the way as we're providing energy throughout the state of New York. There's generally 4 mega trends that we recognize as we're building our programs, and a multitude of programs I've talked about already. So on the far left, we talk about decarbonization, identified that as an issue, working very strongly. We've been asked by our legislature to actively go in and set up plans to help our customers decarbonize. So they've asked us to work with 15 of the top emitters in New York State and put together plans for them to go completely carbon free. There's also this decentralization movement going on. When I started in the industry, pretty much everything was a central power station. And now we've really moved toward a decentralized prosumer kind of model where load is active within the system and some of the DERs can participate in markets. Markets in New York State, by the way, have opened up to DER participation. That happened about 1.5 years ago. And so they can actively be in wholesale markets now. A lot of rules around that, like you might imagine, but they're open now. And then there's digitalization, understanding what's happening, what's going on with the system. Really, really critical in order to balance all of these new resources coming in, increasing loads, and then retirements, and what in the name of decarbonization, retirements that have been announced by some of the most polluting. And I mentioned 4, but you only see 3 on the screen because really the big one is affordability. That is the number one dimension and lens that we look at the grid and try to see what can we solve for that. And a lot of times when I talk about affordability, people have different ideas. So I think a lot of people talk about affordability of energy, critical issue for everyone, especially us as consumers at home, but certainly for all of our customers. There's affordability of projects. So if you are in the business of developing DERs or virtual power plants, as we are, for our customers. How do you afford these projects? How are you going to get the funding for the projects? Price of everything's gone up, supply and demand. Everybody in the world is trying to develop these types of resources all at the same time. And then there's affordability without government subsidies. I'm going to talk about that. You'll see it kind of runs through the entirety of this program. And this is really an area where Xendee has really been able to help us build a business model against that. And so we'll talk a little bit more about that and how we can really move the needle and keep that development of DERs, VPPs, microgrids going without government subsidies. And just on that, I just had to put this slide in. I'm a recovering political guy. And so, I have no personal opinion around government incentives and subsidies around it. I see they certainly have played a large part in the conversation in building energy, clean energy resources, DERs, VPPs, microgrids. So I'm going to let I just put into AI, hey, why do governments subsidize clean energy? That was my search at the top. And it ended up coming through Microsoft Copilot. And these are the responses they gave to it. Well, pretty good reasons, why you would do it. It's important to kind of move policy and move the culture in the direction that that we as citizens have asked for. Moving them through, I think there's also an issue of stabilization. And there's a sense to stabilize things by offering subsidies, but then when you take them away, it could destabilize. And so there could be a negative effect. That's why I chose the picture on the right of the Capitol. It's kind of two natures, one positive, one's a negative. And so that's what's put there. So I personally have no opinion on it. I'm not going to offer you an opinion on it. But what I do appreciate is that I do not want to build my VPP program and the balance of being able to provide for my customers the DER resources, the virtual power plants, the microgrids they're looking for based upon the political whims. And so we have tried to build a model that is agnostic to it. If subsidies are there, great, appreciate it. Maybe more things will be built. If not, we want to build against it and make sure that all our projects we build are financially viable and can be built and meet the level of growth that we're looking to do here in New York State.
So, John, if I can add, if I'm catching this, when you were showing resilience as part of an energy system, it seems like you're also building resilience in actually the business plan and your programs themselves against any sort of changes in policy or the politics of the moment. So it looks like there's two types of resilience that you're going after, both from the infrastructure side, but also around the strength of the business case and the programs itself.
Thanks. That's a great observation. I appreciate that, Adib. I've been in the industry for a while, and I've had the pleasure of meeting Dougs. And I don't know if everybody on the call knows who Dougs are. They're not actually people named Dougs. They are dumb old utility guys. And all they care about is reliability and resilience. And so at the Power Authority, we bake that into everything. A, we care about our customers, making sure we protect them, we're giving them the right guidance. And B, the grid. You saw how much of the grid that we literally own and that we operate on behalf of the citizens of the state of New York. So we need to protect that. So we're always careful with that. And you're going to see in here, Xendee has really helped us perfect that for both our model and our projects. So I really appreciate the observation, Adib.
Awesome.
So let me get to why did NYPA get into the VPP business? And so we've got a long history of customer solutions, and we've been working with our customers, and we're told we are a trusted energy advisor to them. We have developed a program to advance those strategic goals of advancing what our customers are looking for, how they can afford it, how do they respond to the needs of the public, of maybe private businesses, of their boards, just their ethos. And so we do a lot of work with them on energy affordability. How do we reduce the energy costs and increase revenues? Looking at clean energy development, market compensation, not ITCs, again, building against that, trying to be agnostic to that and keeping the development on a steady pace, not stalling when there's some change, in a availability of a subsidy. Decarbonization has been a major focus. And we believe we've got a model that really helps that and provides an affordable pathway for clean energy development for those customers to meet their decarbonization goals. Reliability, just always going to talk about it. Enhancing that site and grid reliability, job one. Resilience the same way. And community benefits. Beyond those who are developing and running and owning these assets, we need to care about everyone in New York State. And so this is a major focus for the New York Power Authority and our customers to make sure there's environmental and energy equity throughout New York State. So, we asked the question, how can NYPA empower our customers to overcome the challenge of affording clean energy projects without government incentives? And it's really being able to model, design, and operate all the financial synergies of the existing assets and capabilities. What can your devices do, your thermostat, your air handling units? How do we make them work for you that exist now, and being able to model that accurately from an operational financial perspective? And then also having that techno-economic modeling capability for the DERs we might propose to a customer, and being able to truly understand how that will work within the system with the customers' needs, how they'll integrate with the market, and how we'd move it forward. And most importantly, how they could do a cost avoidance scenario by self-supplying their own energy cheaper than buying it off the grid, and accessing market revenues as a boost to, in addition to just the avoidance of costs, but to have revenues on top to speed up the project payback periods. And so one of the solutions that we've come upon is that NYPA could be an aggregator for a lot of these assets that we've been contemplating and that we've installed for our customers. And so virtual power plants, microgrids, individual DERs, it's really valuable to our customers. We've been in the market for a long time. We have a pretty good understanding of wholesale markets. As Adib mentioned, I personally worked at the New York ISO for 10 years in the planning group and working with the operations group and markets. But NYPA itself has been in the markets for a very long time, long history of understanding those. And again, we are statewide, so we've really got a good representation of what's going on around New York State to bring that to bear and be the point of contact between the customer and the markets. Complex systems that they'd have on their sites, complex markets, we think we can ease that and supplement them in a lot of ways to make sure their projects are successful. There's a long history of operating these assets, and with so many customers that we have, we can create pools of customers to make these aggregations, virtual power plants, and microgrids a reality for them. And even those individual asset owners to aggregate them amongst other customers to move them forward. So that way we can find any latent or unrealized value of that individual DER, and by aggregating, we can synergize it, do the 1 + 1 = 3 type of economic modeling for them.
John, we have a question from Vince. He's wondering how FERC 2222 has affected virtual power plant deployment, and if there have been any obstacles to retail aggregation as a resource.
Well, I'm actually glad I'm on this slide with that question from Vince, so thanks for asking it. And I mentioned previously, so in New York, I'll say when I worked at the New York ISO back in 2015, we had looked at how could we integrate DERs into the wholesale markets. And we had done some pilots and worked some things out. And we sent to FERC in late 2019 some proposed tariff that would allow for the DERs to participate at very small scale. You just need 100 kilowatts and you'd be eligible to participate in the markets. We submitted that to FERC. They approved it in January 2020, so one of the quickest turnarounds I've seen. And about 6 months later, FERC Order 2222 came out. And I think they took the best parts of what we developed in New York. So we've designed our model in New York based upon a long history of New York looking at it, now almost 6 years of having a tariff approved, but almost 11 years of really grappling with the issue. And so the New York model we have today is about 95% of what we filed and has been approved for FERC under FERC Order 2222. So I can speak for New York. In New York, the change has been positive. We're seeing a lot of projects that wouldn't otherwise come on if not for the revenues they can get through this new market participation model. It's really incentivized them to come in, excited the industry, a lot more demand flexibility happening, a lot more of what I talk about with virtual power plants. So FERC Order 22 has been a boost. It's been a spark, and it's not even here yet. In New York, it becomes effective January 1, 2027. So I hope it's the same for all the regions, but just the concept of DERs going in has really been a tremendous spark. I hope that answered your question a little bit, Vince.
Thank you.
Great. And it's really, when you talk about virtual power plants, I ask 10 people what they are, and I'll get 12 different definitions. So I used to work with a lot of attorneys in my career. And so you always start with definitions just to make sure we'll level set, because when I've talked to other people just exactly on Vince's question, will FERC Order 2222 impact a virtual power plant? The answer is it's according to what kind of power plant you're really talking about. And so I'm very literal. I like words. My definition of virtual, I have two that are generally accepted in the Webster's dictionary. One is nearly the same as, so my wife would say, I am nearly perfect, and I appreciate my wife thinking of that. The second is generally, we talk about a virtual meeting, virtual university we have today. It's a cyber unification of multiple assets that are working and orchestrated together as a single unit. And I'll say that's how large hydro plants are. There's 26 operating units within Niagara Falls. And that is essentially a virtual power plant, if you will. It's unified and operated as one. And what is a power plant? Again, all the dumb old utility guys, they told me a power plant is a facility that converts primary energy to generate electric energy. And I point that out because a lot of times when I hear a virtual power plant, they're really talking about what I call a flex aggregation, which are individual unified sites reducing or flexing demand for economic return. Could be a reliability demand response call, could be an economic offer that they've been into the market. But I call those flex aggregations just for ease of discussion and for regulatory consideration to understand these are very, very different operations and very different contributions to the grid. On the right-hand side, I got a big old circle in there. And it's just to give an example. When I talk a lot about monetization of sources, value streams, I'm talking about things like feed-in tariffs. In New York, we have the Value Distributed Energy Resources Tariff. It's sort of a net metering 3.0, I think we're at right now. You have wholesale markets, the New York ISO, any of the ISOs, RTOs. You have utility programs, non-wires alternatives, and all the other bridge-to-wire programs that a utility may have. And then there's self-supply, right? The cost avoidance I mentioned earlier. So you're able to provide your own energy and then potentially at a lower cost according to what resources you're using. Then on the lower left-hand side, this may throw some people off, but I often will talk about optimization of contracted and reduced cost supply, electric supply. And what it really is about priority low-cost tranches of energy supply. And that could take the form of a great bilateral contract that somebody has, and it's well below market, and that's fabulous for them. In New York, some of the power that the New York Power Authority generates is economic development energy allocations. So someone that the state is incentivizing to come into New York State, they may say, hey, we can give you some of this power from Niagara Falls lower than the market rate that we would sell it into the New York ISO markets to help them as an incentive to come to New York State and create jobs. But then there's also a new tranche out there, which are these prepaid supply contracts. You make a pretty good estimate of what you think you're going to use. You can work with the New York Power Authority when we'll be offering it, and you would be able to then get a lower discounted rate from the market rate as well. And so these are all lower cost than what you're going to get off of the market purchasing from your utility. And so you want to be able to design with those in mind. You just don't want electrons from anywhere. You want to protect that. And again, one of the things you'll hear me talk about is with Xendee, you can customize it pretty well, pretty robustly, and to be able to protect against those. So just with that level setting, unless there's another question, I'll go on to the next slide.
But thank you.
So as we kind of figured out, what the words were, then we got to figure out, well, what model would we do? And this slide's going to be very quick. We looked out there and looked at all the reports that are on the middle of the screen and many, many, many others. It'd be easier if someone already did the work. I didn't have to build it. And we found for our large customers, our C&I customers, our New York City Housing Authority with nearly 500,000 apartments, these models don't do much. And as far as decarbonizing your site, bringing in tremendous revenue, making great savings, demand charges, yep, these work pretty well. These are great models for our customers. These probably weren't going to be as useful as we thought we could be or should be on their behalf. So these are the common models. And we started out and we said, well, this probably need to go and look a little bit farther. And then I had to figure out, well, what would it be? And then what would be the concepts to see if a program be scalable? If a project's scalable, then maybe a program be scalable. So I came up with, I call a 3D conceptualization of scalable VPP program. And it starts with looking at all the government policies, utility tariffs, customer goals. And what you find when you lay out all these tariffs and everything, they're not really aligned well. They're usually very misaligned. But then you have the customer's goals. What's the customer want to do? And you find that doesn't align because they can only do certain things or their goals exceed or somewhat different than what has been put into policy. And then so when you put them all together, you see the overlap area, and that's your VPP program potential. That's what you have to work with all of the entities on the regulatory side, right down to the customer side. And so that defines the potentials, the parameters, and limits for how we would develop DERs and virtual power plants. In order to do that, the number one thing we needed to start with was design. This is when I first called Xendee. It needs to start, you have to be able to design your project in order to contemplate, is it scalable? And as a business, is it scalable? So with the design, we're looking at what is the hosting capacity of the site, the technologies, configurations behind the meter, front of the meter, because I can access different value streams with different configurations. In New York, we can hybrid. I can have some assets behind the meter, some in front. So how would we move that forward? Then you'll look at debt. How can this project potentially be financed? And what are the implications from the design? Because again, we're looking at value streams and configurations to, is it a PPA? What would that be as a financial structure? Are you self-funding? You have some liquid capital available to you. Bank debt, you're going to have to identify with that debt, how you're going to pay it back. Many of our customers, they may have noticed, are government customers. So there could be state and federal funding. So you still want the money paid back. And then there's how do you operate it with the DERMS. So I have designed debt and DERMS. A little alliteration goes a long way. But it's really, how we're going to operate these, how are you going to pay for it, how you're going to design it. Because if you can't operate to the goal, then it's not likely going to be scalable. You need to understand your site load versus your exports in order to get your sizing and your economics right. You need to understand your least cost energy optimization, which is a rare thing to find in a modeling tool. And then if you are in an area that has flexible interconnections, you're going to need to operate within those limits. So the DERMS becomes really, really important. And what you see when you have this sort of a diagram is where the intersect gives you a lot of really important information. So between design and debt, that's going to define for me my payback period for my project. And then as I go over to the left between design and the DERMS, I'm going to know if I can optimize to what I designed to and vice versa. So they're going to be iterative and feedback loop in order to understand what we can do and what we can't possibly do. And then the intersection between debt and DERMS gives me a forecastable revenue. Whatever financial paradigm I'm in, you want to know what your revenues are going to be and forecast it. If you go to a bank, they're going to ask you, when are you going to pay me back? How are you going to do it? If you can forecast the revenue, you probably are going to get the loan. And so if you have all that aligns pretty well, and debt and DERMS, and it falls within the policy envelope, you have to be within the policy envelope, it looks like the program could scale. So we said, we think we've got something. And again, it was based upon our ability to design. That was the starting point. Again, that's when we first called Xendee. And we said, hey, Xendee, we have all of these things that we currently do. We do a lot of energy efficiency. There's demand response in our system. We're building DERs. How can we orchestrate all of these assets together into something that's useful and work it out? How do we maximize affordability for the project, decarbonization, reliability, resilience? And then, like I said, for the individual DERs, maybe it's a synergistic aggregation. There's a bunch of batteries in the Bronx in New York City. They're not related in any way, different, owned by different customers of ours, but we can aggregate them and put them into an ISO program, and you get a lot more revenue than if we operate on them individually. And then it's
John,
how do you optimize the contracted and reduce cost apply those tranches I talked about, and how do we do that? And so this really, we started now being able to say, we do these now, we understand these assets. Now we're looking, we think we have a model that can work. So what exactly could that look like? Again, I'll take a breath just to make sure if there's any questions.
John, I have a question regarding the financing that you had on the previous slide. What has been the risk appetite that you've seen from the banks, like the New York Green Bank, for example, or similar other ones? How has that financing evolved based on what you've seen and the experience that you have in this area?
So stability and certainty in the markets is critical in order for the green bank to want to get money out. And if you can walk in with a forecastable revenue and say, I can understand where I am in the markets, I can understand where in the value streams I'm falling, the dollars tend to flow more easily. There's been a lot of subsidy. So they'll say, well, gee, if you're subsidized to this degree, it's a much smaller amount that you're going to need to pay back. And so they've been more favorable with the elimination of the ITC on the solar side. And, we don't know what'll happen for the battery side of it. It seems to have gotten tighter. And so more and more, it seems that, this paradigm where I've tried to put together, could it be scalable? And that understanding of what you could design to and what you can operate to in order to have a forecastable revenue stream, I think it just makes it easy for no matter what financing you're going after and how you're funding your project.
Okay. Awesome. Thank you.
So again, I talked about, so that's when I first, I think, ever spoke to Adib and met Adib, and we came into, we have an idea and we'd like to move it forward. And so we sought out a really comprehensive modeling tool and what could it do for us to move for our DER resources, for our virtual power plants, for microgrids and aggregations. And the more we were out in the marketplace and talking, we came up with a set of criteria. We required a modeling platform that provided technical engineering models and energy market economics, and then the operational capability and value of a customer project. And so as we looked at Xendee, these are what we discovered is that they'd have integrated value stream optimizations, really helpful, really useful to us. The most important thing was they were customizable. We spent a significant amount of time with Ray and his team consulting to us to customize our version of Xendee. And so we have the design tool. And so they had all the value streams and the capability to have them in there. New York's were so new. And again, we're kind of ahead of the curve with FERC Order 2222. And so we have these various value streams, a lot of rules. I call them mutual exclusivities. I can be in one program, but not at this program. I can't sell the same electron twice, and to bake that all in. So that was really critical to say, we think this tool is really helpful. And as the market evolves and new rules will come out, we can bring them in fairly easily now into our iteration of Xendee. And then market awareness, dispatch, and price signaling, looking at real energy prices and able to put in forward-looking models on forward energy prices. So in NYPA, we have our own energy economics team. They spend a lot of time looking at that. We could put our models in with our intelligence into it. And so that makes it a really powerful tool to be consistent with how NYPA looks at all projects that we'd be looking at going into the market. And then simultaneous multi-market optimizations. Absolutely incredible for us because we are allowed to have dual participation. You could be in, utility programs, retail programs, wholesale programs, wherever you can get the value stream if you meet eligibility criteria and you don't violate these mutual exclusivity rules. So really important for us to understand and optimize it because again, for us, that would go into my project configuration. Do I put some assets in front of the meter and some behind the meter, all behind the meter? It tells me that, gives me the design that I would work with. What are the technologies I'm using? What are the sizes I'm going to be doing? And I'm literally building and designing to the value streams I think would be optimal to meet the customer's goal, give them that capability and affordability of the project and ongoing revenue cost. And then you always need a holistic modeling tool in order to move it forward. And again, I mentioned at the front, an absolute requirement was understanding the engineering constraints. So all the power flows, reliability, sizing, things like that, financial metrics, net present value, RRR, cost of energy, and then the market value. What are these revenues coming in? And so we found that Xendee's design tool was just really instrumental in allowing us to get what we thought was the most comprehensive and deep picture that we needed to feel responsible in giving a customer a project. And again, it was realistic modeling. And the results we were seeing, we tried to M&V them against anything we had, and it looked as though these were bankable economic results going forward. So Xendee really helped us kind of get our feet on the ground, help us kind of figure out what we can do with the knowledge we previously had, the resources we had already built, and then move it forward into what we think would be a great economic model for our customers, an operational model, which is virtual power plants. And so we had this dream. This was our dream. We can have all these types of assets in cities and individual sites and large aggregations, and on the upper left-hand corner, large renewables and large battery systems coming in. NYPA sits in the middle as an aggregator. We're going to be working with the ISO on the upper right-hand corner, communicating with them, communicating, dispatching with the utilities in New York State, because then we are all over the state of New York, so every utility. And this became our vision. And this was really the techno-economic modeling capability of Xendee is really what got us there. It was our foundation to being able to have this dream. And once you have a dream, then you start going a little bit crazy. And we came up with 3 products we thought could constitute a program. And so just very quickly, a turnkey service. You give me the keys to the kingdom. You come in, you say, here's my building, here's what I'm doing, here's my goal. Design for me. Design what size, what technology, where I need to go. Here's my goal. And the goal could be decarbonization. It could be resilience. It could be economic. Cost of energy and or cost of my project in order to get there. We're able to do that with that turnkey service. Turnkey is exactly what it says. We design, we build, we even would operate these sorts of programs. In the middle, aggregated market participation. I mentioned it a couple times. The individual DER that's out in the community, and we can get a little bit more revenue, help that customer meet their goal a little bit more. And as they see more revenue coming in and more market opportunity, maybe they want to build the next device, the next DER, and go quicker and more assuredly in the most cost-efficient way toward what's the next best step to decarbonize or increase their economic profile for it. And
John,
the third,
do you have a feeling? Sorry to interrupt. Do you have a feeling for which one of these solutions will have the most popularity, or is there a trend you're anticipating or seeing around these 3 products that you've developed?
Well, I'm just going to mention the last one, Adib, because I think I'm just going to mention it to answer your question fully. And so on the right-hand side, it's really In order to do the first two models, we now have capabilities, which would be going in and doing a site and resource planning assessment, otherwise known as doing a Xendee design run for them. Putting them on a DERMS. We have a DERMS. We can put you on a DERMS to operate to it. And there's different reasons why. It could just be rate optimization for all those sorts of things. And then we're here as market participants, the largest in New York State, to help and advise our customers. So it's according to who you are, Adib, and what you're looking for. I think a lot of folks will want us to do some site resource planning assessments using your design tool, figure out where I am, wherever they are on their path toward whatever their goal of those three dimensions, resilience, economic, and decarbonization. We can identify for them a pathway on where to go. They just need to tell us what to solve for. And we can, as you know, we can co-optimize that. So if you say decarbonization, you find it's really expensive, hey, we could build on economics and I can scale them to get the right fit for the customer. And so that usually then tells them which one of these they want to move to. Will they want to do it aggregated? Hey, you know, I've got a battery, not really sure I can afford to build anything else. Let me jump in with the battery and then a communal aggregation, if you will, see how that goes. But hey, give me a pathway, give me a plan to get to 100% decarbonization or more hours of resilience. So it could go that path, or some will just look at it and say, you know, my board of directors or my regulators are requiring me to fully decarbonize. Here's the keys to the kingdom, go. And so we're seeing it, and we're just really getting the program, you know, stood up to be offered to our customers. So, but the interest seems to be, do a study, help me figure out that pathway first. They have an idea of where they need to be. They don't know how to get there and what it would cost. So that's really where I see the first instance is going to be the rush. And then they will go to, if you're large, if you're small, if you're upstate, if you're downstate, and that'll help decide those models.
That's really powerful, John. It sounds to me as if NIPA is really engaging as a trusted partner to really help with the strategic thinking and planning for the customer, which really means you're getting into that conversation right at the most critical point with them, and then being able to provide them with a fairly sophisticated roadmap based on the strategy that meets their objectives as cleanly as possible. That's great to hear.
Yeah, I'm on the customer solutions side of the business. I was on the more utility side of the business. And I can just tell you, customers, NIPA's focus is customers. And we've got the ability, and fortunately, we're our own revenue producing entity. We don't take tax dollars. And so we put customer first. We want as much revenue going to the customer as possible. So my business model isn't I have investors to feed. I need to go forward. We can really move through altruistically to bring to bear all the capabilities of the Power Authority, our years of knowledge, to help them transition to where they want to be. And again, the tools allowed us to do it. And it's really for us the next evolution of what we've been doing for them. But it's a really powerful capability I think we can really offer our customers now.
Yeah, that's awesome. That's really awesome. There's a question. Would NIPA operate the programs in-house, and if so, why?
So we actually, if we're operating a virtual power plant, as we have a DERMS vendor, we are first looking to partner with them. And so we would be NIPA would be taking a position as the customer's advocate. So we would have the DERMS provider also providing the turnkey operations. So they'd have the NOC and they would be monitoring. We also would be like a super administrator with all of our customers seeing and taking a position of advocating on their behalf. Because of the newness of the program, we felt that was a very risk-averse way to move forward. The last thing that we want is our customers at risk. And as it's a new program, we want to make sure we've got skilled eyes that are focused on it. We can look over their shoulder and learn. But we certainly are envisioning, because we do energy trading literally every day, that would be coming in-house when we felt that we have mitigated that risk completely for our customers.
So thank you.
Great. And so I am going to give you a real quick discussion about one specific the turnkey model I mentioned, and I'm going to really quickly run through some of the results we did in doing this. So the turnkey model, we really focused on affordable decarbonization. I literally know that's what it achieves. It's really, the first goal is maximum decarbonization with optimal economic operational impacts, shortened project periods, optimization, least cost supply, resilience. Second goal is overcoming dependence on government subsidy. And again, because I don't want my customers at risk for changes in political winds. So when I do runs for my customers, I don't include ITCs even when they're all there. We didn't include them. Can we make it in the market? Can the market value it? That will give us persistence in the market, value in the market all along the way. It also adds resource adequacy, helps alleviate transmission security limit violations, all these good things we want to overcome, and more supply, meeting equal demand or some slightly slower growing demand, is going to put downward pressure on energy pricing. So we're always looking for optimal technologies to get to the customer's goal, how we configure them, the design, a lot of things I've talked about before. And so we've moved through and really made a whole model to that, but it's really designed for our very large customers. It's not a residential model. We don't serve residential beyond housing authorities. So it's really focused for those customers. And just real quickly to go through, as we were working with one customer, I'll talk about from now on, they were in the middle of an OSHRA level 2 audit. And so we said, what a great opportunity to test out. We've got this cool design tool that we can work with. What would it be if you went through what I call the traditional energy efficiency demand response model? So we said, hey, ask that consultant to run a 3.5 megawatt PV system, a 2 megawatt battery, and go see what the results would be like. And let's compare it to what we were getting with our model going for revenue. And so on the left, on the far left of the left chart, you'll see it's kind of yellow color, and that's the batteries charging from the grid. This expands in the pink line above it is the battery charging. And the blue line is the building load shape, which, by the way, this is the exact same building. So you see the load shapes are similar. And then we had told them the sizes. They actually made the solar array smaller in order to not have the payback period be so prohibitive. They kept the battery size about the same. And as you see, they just go to building load. And so it's a pure cost avoidance scenario. Self-supply, I avoid the cost of that. And the payback period on that was 3 to 4 times the asset life. But as we're able to model it using the Xendee design tool, we're also charging from the grid in the morning. We've got some grid energy coming in while our solar array is picking up and it's meeting building load. We see our batteries charging with the pink line. We've got the solar array coming online. We're now exceeding early on the solar array. That's an export. That's a sale we can make. We have many hours through the year we can have sales and be in the markets. You'll see the green at the very top in the middle hours. We're discharging the battery those hours. Xendee has helped us figure it out. These are really good hours in order to make, a great offer into the marketplace. So we've got a good energy arbitrage happening there. Also, by the way, a carbon arbitrage, because you see we're only charging the battery at night from the solar, very little carbon at high carbon dense hours of the day. And then Xendee modeling has told us that, keep our powder dry for a couple of hours, even pick up some grid energy, because they see an opportunity when everybody's driving home, but your office lights are still on, that we can make some more money in the marketplace. And so when you look at the difference in these, you see the project payback period from the old traditional model of cost avoidance was 3 to 4 times asset life, which doesn't make a heck of a lot of sense to me to pay for something when you've already thrown it away. And on the right, we're able to model by pursuing revenues and optimizing all the assets, a project payback period well within the asset life. And so with that, the customer decided to move forward with us. We designed it. There's, gives you an idea of what it was with 3.5 megawatt long span carport solar. They went with a very expensive configuration for the solar array, a battery to it. The project cost, I have another slide that'll go through it. But as we went through all of that, the topic of ITCs came up. So you saw this slide earlier, and it's just a reminder from me. It really was difficult for the customer. Can we afford it? What can we do? It was, again, we have faith in the model. We have looked at this model many ways. So we had comfort with the model. So we're able to convince the customer, go ahead without the ITC. I've never included ITC in any number I'd ever given them. So they felt pretty comfortable. We moved forward with it. And this is what the project ended up looking like. These were the financial metrics for it. So the total project cost was a $31.2 million project. We were going to be able to take in revenues of just over $1 million. Annual O&M was $338. The net annual benefits, $681. That's a pretty good annual benefit from it. Value of the social cost of carbon, $210,000. And we were able to completely eliminate greenhouse gas generation from that site. And on the right is just a picture of the assets and where they are. You've seen these on your Xendee models. I'm assuming most people are running Xendee at some level. Here's the detail behind it. I mentioned earlier, there was an OSHRA level 2 audit going on. And so we were able to get that chart that was on the left. And so the fruit of that was that they identified a number of ECMs that they wanted to implement. So we were able to take the baseline on the left. It was year 2023, 8760 hour interval data, and then modeled all of the new ECMs that were going to go on. And you'll see, of course, geothermal conversion is going to increase your electric consumption. You came off the natural gas, and then how it cascades down. And then the ECMs alone gave a 22% reduction of energy consumption on this project. But once we put in our battery, once we put in our solar array, and then we've put it onto a DERMS where we can control it to the design we had initiated with, we're able to reduce it an additional 46%. So for a 68.2% reduction in electricity consumption for this one project. We looked at it through different ways. So cost is going to follow consumption, right? So same sort of chart. And what we see is the geothermal increases the cost of electricity a bit in here. But with the VPP, we're able to supply the least cost electricity mix to meet that increased demand. And so the savings to the customer was pretty dramatic. And again, from their annual bill, it came down 66.4%. And then that would be persisting through the life of the project going forward. So state tax dollars not going to pay someone's electricity bill, hopefully going to healthcare and other good stuff. And then as far as greenhouse gas emissions, again, we have our baseline. We put in all the ECMs to all cascade downward, and that achieves about a 37% reduction. But again, because we were able to size these assets appropriately, we were able to understand our interconnections. Well, we need to have huge interconnection costs. We modeled all of that utilizing the Xendee design tool, and then we were able to literally eliminate all the greenhouse gas emissions from that site. And so what that, and it's actually, because it's a waterfall chart, it only goes to 100%, it was 104%. So even though we took from the grid, we exported more to make up for that. So it was a complete energy decarbonization. And in the end, this is just a unified chart of all three of those to show them going across. And so the top line was the consumption, improved it from 22% to 68% with a VPP design to it. On the ECM side, reduce costs, going from 32 to 66. And then on the carbon decarbonization, all the way up to 104%. Pretty successful project. Was likely, we're assuming likely to be fully developed within the next year, hopefully be in construction within the year, and move that project forward. These were the benefits as we were able to calculate from them and pulling from the policy. It's maximizing that decarbonization, and it's absolute decarbonization, meaning non-conditional. You're not buying a REC, you're not buying a financial instrument. You're literally eliminating carbon from that site. The energy cost reduction we talked about, increase in reliability and resilience. They had a diesel generator. If it's ever turned on, it may be turned on in order for a long duration, but it's not likely it would be needed. Grid enhancement for the community, less congestion in the area. They're self-supplying. All blackouts in New York City were calls on transmission. This would make them able to essentially island if they really needed to and be considered a microgrid. Revenue generation, you saw over $1 million worth of generation. Again, we were able to configure it behind the meter, front of the meter, size it, decide what technologies got that customer's goal. And then we also offer NIPE as a turnkey partner, utilizing our unique experience and knowledge of the grid and system in order to help our customers out. And that's all I have. That's my presentation. I hope it was useful. And if there's more questions, those were great questions so far. I'd be more than happy to take the next couple minutes.
John, this was such a great presentation. Personally, I learned so much, and I'm grateful to you for sharing of your experience, kind of the challenges, how you approach them, and the solutions, and seeing the savings along with the decarbonization happening together is really not just impressive, but just I'm really happy to see that. And just at Xendee and myself, we're so proud to be part of your team partner and supporting these important initiatives for the New York Power Authority and your stakeholders. And I also want to thank the audience for joining us and the engagement. There's lots of questions. I don't think we're going to have time to answer all of them. We have another panel coming up where we will answer them and get them answered offline for those folks. And it was, and the recordings will be available as well. But this was such a really compelling story. I mean, you walked us through everything from how it all came together, what the challenges were, how you really approached it in a sophisticated manner, and then just the benefits not for the greater community, but also from the customers themselves. I really enjoyed being in conversation with you. And for the audience, please join us for the next panel as well with the Sacramento Municipal Utility District and Pacific Gas and Electric. But John, thank you so much. This was awesome. And
thank you,
Adib. Look
really
forward to our
it.
continued partnership with you and your team.
Me too. Thank you. Goodbye,
Thank
everyone.
you, everyone.